welcome back everybody. Let's take a look at 56, 58, 59, and 60. We'll do a partial look at 57, but we'll hold off on that one. So 56 asks for at what value of x does the slope of the function, and they give us the equation, equal 4 pi. The important thing to recognize is that the slope of a function is a fancy way of asking you to take the derivative of that function. We happen to have a polynomial. Thankfully, we can do the polynomial trick for the derivative, which involves us bringing down the exponent, subtracting 1 from the exponent, and then so on and so forth. So from there we get 2x minus 35. And then that constant there, well, it's x to the 0. We multiply the 0 over, right? That's one way you can think of it. And so 0 times whatever, right? A constant contributes no change to the function. It does not contribute to the slope. Okay, so from here we solve over, we subtract the 35, and then we divide the 2, and then we have our x value. For number 57, this is an optimization question, and this is one of the more elaborate optimization questions I have ever seen. In this case, we have to optimize the cost involving a path, and so we're going to have n amounts of stones, and we can choose between 12-inch stones that cost $1.58 and 16-inch stones that cost $2.50. And they ask what stepping stone dimension minimizes the cost. We're just going to talk about the setup here, but we're not actually going to solve it. The important thing to recognize is that the total cost of this situation is going to be the n amounts of stones times the cost function, but the total amount of stones is going to be a combination of 12-inch and 16-inch stones, which I'm calling x and y respectively. The other bit of information is that we have to use their cost to find out the constants of this equation. So we can do a system of equations, two-system solver, and find the values of m and c. So we plug in x times this cost function, y times this cost function, or really n minus x, and we take the derivative. And the important thing is that whenever we are at an optimum value, the slope or the derivative is going to be 0. We'll leave it at that for this question. 58, they ask what is f(2,3) if f is going to be equal to 13 times g plus 22 times h. They give us the values of these two matrices. So what we have to do is we put this into the matrix or matrices, and we do the math operations. 13 times this guy is going to take 13 times 9, 13 times 14, 13 times negative 19. It's going to multiply every element through by 13. Then we're going to take h, multiply by 22, and every element there is going to be multiplied by 22. We add them. And the question is, what is the value f(2,3)? So the way we go is this is 1, 1, this is 1, 2, this is 1, 3. So the row index is the first number here. So this is the row, this is going to be the column. We're going to go to the second row, 14, 9, and 3 would be the second row of this matrix, and this would be the 2, 3 element in that matrix. Anyways, you evaluate the matrices based off of this formula that they tell you to do, and then you're going to get the value that is on the second row, third column. Let's continue with 59. 59 is, thankfully, a straightforward question. They want us to get the hatched area of this function, and they give us the function is equal to 6 times cosine of x times sine of x. And from there, we're going to want to do an integral, and we're going to integrate from 0 to this point, which is pi over 2. Pretty straightforward. All right, last question here in this rotation. They want us to find the distance AB, and they tell us that the area of the circle is equal to the area of the square. Now what we can do is, well, they give us the radius. And what this lets us do is it lets us relate the side length of the square to the radius of the circle. Now let's go ahead and look at what they want. They want this distance here. How the heck do we do that? Well, we're gonna have to build up the distances. If we go horizontally, the distance from here to the point of contact is the radius. We have that number. Now if we continue all the way to this vertex, that's gonna be a distance half the diagonal. So I'm just gonna write that as diagonal over 2 for now. So this whole distance is gonna be the radius, which is 0.539, plus half the diagonal. And using this formula, we can relate the area of a square to the radius, or really the side length of the square to the radius of the circle. And then from there, we can get the diagonal. Don't forget, the diagonal of a square is going to be square root of 2 times the side length. The last thing that we do here is we compare the vertical part of this imaginary triangle. The distance to this point right here is the radius of the circle. And the bit leftover distance right here is going to be half the diagonal minus the radius. And so that's what we get right here. Alrighty. So give me 1 second. I'm going to try to write the expressions here for the circle, radius, the square of side length, and the diagonal. So let's see here. They tell us that it's going to be pi r squared equals side squared. And so the side is going to be equal to the square root of pi times the radius squared. And they gave us that number there, so we could get that. And then the last thing that we need is the diagonal. The diagonal is going to be square root of 2 times the side length. So the diagonal in this case is going to be square root of 2 times the square root of pi times r squared. Okay. If we wanted to, we could clean this up a little bit further. That becomes the square root of 2 times pi. And then the square root of r squared is just r. And so we can do that, and we know the radius. Alrighty, thank you everybody.